Hello everyone, good day and welcome to this session. Today, I'm excited to show you how to create these well-designed elegant residential towers using Autodesk Revit. I'll start from a simple curtain wall and gradually build up detailed facade elements like frames, balconies, and recesses. The actual towers are 40 stories tall, but for this demonstration, I'll model two towers at 25 stories, about 62.5% of the full height. This focus will be on using parametric families and curtain wall settings to efficiently create a realistic architectural model. Without further delay, let's get started with Autodesk Revit. First, I'll create a basic curtain wall, using shortcut WA. I'll set the width to 33,000 mm and height to 33,000 mm. This form will be the base of tower referencing. Next, I set the horizontal and vertical grid spacing to 3,300 mm. This represents the size of each residential unit's frontage, assuming square shapes. I also remove all mullions by setting them to none, so, can start with clean, simple panels. Initially, all panels are glazed system panels, ready for further customization. Now, let's create first customized family, it's the frame. I start a new metric curtain wall panel family. To do that, I start a new metric curtain wall panel family. I add reference planes, using shortcut RP, to define the exterior and interior edges. Facade D for facade depth. Instance parameter set for varies and unit D for unit depth. I add more horizontal and vertical reference planes inside with dimensions. Dimension them and naming the parameters. To set the facade thickness, facade T as instance parameter. Using these planes, I create extrusion geometry for the frame. Align to reference planes, shortcut a L, and locking everything in place to maintain parametric control. Duplicate a same extrusion geometry for interior. Align to reference planes, and locking everything in place to maintain parametric control. I assign two material parameters. One for the exterior facade and one for the interior residential unit. Test for parameter before load into project. Facade D to 350 mm, for thickness 250 mm and unit D to 500 mm. After testing to ensure parameters work correctly, I load this family 1 into the project. To proper family handling, rename it to frame. Same name for family type as well. And replace the default 1 panel with this new family frame. Shortcut, SA for all panel selection in curtain wall and replace with frame family. To apply with material, choose this. Render beige smooth material for now. Second family, is this. Recess family with sill. Next, I modify the frame to create the recess family by adding a sill 300 mm extrusion component to the facade, modeling in left and exterior elevation. I ensure the sill is aligned to reference planes and joined to the main geometry. Making it a single, complete element. Load to the project again. This family is still with family 1, I'll rename and project later on. After loading this family into the project and renaming it recess. I replace some of the panels to add variety to the facade. To apply with material. Third family is sketched it out something like this as balcony family. Moving on to balconies. I modify the recess family by removing the sill and increasing the facade depth to 1,500 mm. I add a glass railing using reference plane at 100 mm fixed offset and 1,200 mm height. Then, creating 15 mm thick extrusion geometry for the panel. Assign material to glass. Once refined, I load this as the balcony recess family. And replace selected panels with balcony family. Testing parameters to ensure it adapts well. Fourth family sketching in like this as balcony but with opening at both sides. Continuing modify with family 1. To add complexity, I create a balcony with side openings. I add a vertical reference plane, dimension its size to define as facade T. For these openings, create void forms in left view and to cut through the panel. Ensuring to align and lock them. Additional glass railings are added on both sides as well. Again using reference planes and extrusion. Ensuring to align and lock them. To apply with material. Now, I've upgraded to family 1 again, to load the family. After loading family 1 and renaming to balcony recess with sides. I replace appropriate panels to enhance the design. Next, going for fifth family. I create a cantilevered balcony as simple. I remove existing components and recreate a solid slab extrusion for the balcony floor. Ensuring to align and lock them. For the railing, I use a sweep modeling, sketching a path with profile along and 100 mm offset reference lines from edge, to create a perimeter glass railing. Ensuring to align and lock them. To apply with material, load the family into the project. Renamed it into balcony cantilevered. And panels are replaced accordingly. I adjust the facade depth parameters to fit the design intent. To this family facade depth with 1700 mm. Next family depth D to 1000 mm. Recess family depth to 700 mm. All are works properly. Upgrading families with doors, windows with frames. To add realism, I upgrade the families with door and window details. Start to modify and upgrade recess family. I create extrusion frames for windows and 40 mm by 100 mm depth frame, ensuring to align and lock them. And material to create with DW. And, adding reference planes offsetting equal 3 bays to control positions for perimeter frame, ensuring to align and lock them. Join to the main geometry window frame into a single internal rails and 1200 mm horizontal rail from base. Ensuring to align and lock them. Join to the main geometry window frame into a single, complete element. Add a glass window to complete family. Load and overwrite with existing recess family to upgrade in the project. Next one to upgrade is balcony family. I create extrusion frames. I apply similar upgrades to included doors and its frame, by adding reference plane's name with DW to determine the frame position. Align to reference planes. And, adding reference planes offsetting equal 3 bays to control positions for perimeter frame. I add additional 3 reference planes for 3 doorways and named with D1, D2, D3 to overlap the panel placement with a gap correctly when modeling each panel. I model the door frame size with 100 mm by 20 mm thick. (250 mm to bottom rail). Glass panels are added for door leaves or modeled with proper spacing. Once all elements added in, load the family to project. Overwrite the existing version for upgrading the family in project. Yes, I'm done for first family, like these. All good. I apply similar upgrades to the balcony recess included doors and its frame, by adding reference plane's name with DW to determine the frame position. Add an additional 50 mm thick handrail on the glass panel. Load and overwrite the existing version to upgrade the project components. And, also, I apply similar upgrading process to the balcony recess with sides families, adding door frames and door panels. Load and upgrade components in project. The cantilevered balcony family is also upgraded with door panels. All families are loaded back and overwrite the existing ones in the project. Not only these, I create an additional new fixed glass recess family type to install as well. Referencing to recess family. Create as new recess fixed family by just to remove the sill and horizontal rail. Then load and install. Now for the final assembly and parameter adjustments. I duplicate the curtain wall and increase height to 25 stories and 99 meters in height. Replace all panels with frame families and apply material. I test for recess fixed with some panels from below 4th row and new full tower curtain wall. First approach with, shortcut, MA, match property selection and, by other way, multiple panels replaced by window selection. Then, I replace all panels to recess panels, except top 3 rows. These panels variation at 2 columns. Adjust 500 mm to facade depth. I carefully replace panels with the newly created families. To apply with material, Adjusting facade depths for visual variation across the tower. Then, remove the sample curtain wall from project. Large frame components are added by removing curtain wall grids and replacing panels with oversized frames. Apply facade T, thickness 500 mm relatively with its size, and facade D, depth to 2000 mm. Material are applying for those as well. To simulate interior residential units, I increase the unit D depth parameter in all panel families, and materials are applied for interior unit components. First, to select all frame components, increase the unit D depth to 6000 mm in family type properties. Materials are applied with paint white lining for now. Next, select for all balcony recess family type, unit D depth apply 6000 mm. Then for balcony cantilevered components. For all frame panels as well. Finally, apply unit depth to recess. According to the images, both upper and lowest 3 rows are not required to build the units. I select the huge frame panels on the rooftop level. Modify the unit depth amount to 0, it might break with its parameter. To be clever, input should be 1 mm for ignorable thickness instead of none val 0. Apply to remaining frame components at top 3 rows. Input 1 mm. Also to do all panels at bottom 3 rows. All good. For the visual effect, shadows enabled, and adjust lighting levels. I install structural columns on level 0. I include more feature, such as public decks, another slightly wider deck it's below. And green lawn areas are added to entire premise. Also, additional curtain wall is placed on the tower side. Shortcut, SA for all panel selection in curtain wall and replace with frame family. To apply with material. And load with empty panels inserted for openings. Adjust the frame depths for some components. I do copy mirror image for other side and curtain wall. Finally, built up a tower, next to it in a second. I duplicate the entire setup for the second tower. But both towers in placed with single face facade to reduce the memory usage and demonstration only. Planning to be done in the premise. And add entourage elements for realism. Also add, inside residential unit. These are some detail images available in model. Some engineering views in details from top, or, below. This is site plan, it will be differed with actual site, just to model for content creation and study purpose. Front elevation, side elevation and a part sectional view. Some 3D views. Partial views sighting for lower part of tower. Just to step in under it. This is this. To summarize, I started from a simple curtain wall and progressively enhanced it by creating and upgrading various family types for the facade, frames, balconies, recesses, and cantilevered elements, adding depth and complexity to transform a flat wall into a dynamic residential tower. This approach demonstrates the power of parametric modeling in Revit. Thank you all for your attention. I hope this session has been insightful, and I look forward to seeing you in the next one. Have a great day. Thank you, bye.